Welcome, everyone. Today, we're going to explore the fascinating world of linear equations. On this first slide, you'll see the title Linear Equations, which is the focus of our presentation. We'll also touch on what you can expect to learn, from understanding the basics to solving different types of linear equations. I'm excited to guide you through this topic, so let's get started. Today, I want to focus on a fundamental concept: one variable. When we talk about one variable, we're really looking at how a single factor can influence a certain outcome or behavior. This is important because isolating one variable allows us to understand its specific impact without the noise of other factors. By examining this, we can identify direct relationships and make clearer, more targeted decisions. Throughout this presentation, keeping our focus on one variable at a time helps us build a solid foundation for understanding more complex systems later on. So, let's explore how focusing on a single variable can simplify analysis and lead to more precise insights. Today, let's talk about what an equation really is. An equation is a statement that shows two algebraic expressions are equal. You can think of it as a balance scale, where both sides need to be the same. The key point here is that an equation connects two expressions with an equal sign. This concept is fundamental because it allows us to solve problems by finding the value of the unknowns. As we move forward in this presentation, understanding equations will help us manipulate and solve more complex algebraic problems. Remember, at its core, an equation is simply a way to express equality between two algebraic expressions. Let's talk about linear equations in one variable. When we see an equation that involves only one variable, and it's of the first order, we call it a linear equation in one variable. This means that the variable appears only to the first power, and there are no exponents or roots involving the variable. Recognizing these equations is important because they form the foundation for solving many algebraic problems. They are straightforward and often serve as the first step in understanding more complex equations. So remember, if an equation has just one variable and is linear, it's a linear equation in one variable, and solving it is usually a matter of simple algebraic manipulation. Let's take a look at the properties of an equation. These are really key because they help us understand how we can manipulate equations without changing their solutions. First, if we add the same quantity to both sides of an equation, the overall sums remain equal. For example, if x equals 7, then adding it to both sides gives us x plus a equals 7 plus. Next, if we subtract the same quantity from both sides, the differences stay equal. So, starting again with equal to 7, subtracting a from both sides results in x minus a equals 7 minus a. Moving on, if we multiply both sides of an equation by the same number, the products are equal. For instance, if x equals 7, then multiplying both sides by a gives us x equals 7a. And similarly, if we divide both sides by the same number, the quotients are equal. So, divided by a equals 7 divided by a. These properties are fundamental because they allow us to isolate variables and solve equations systematically. Remember, the core idea here is that these operations, adding, subtracting, multiplying, and dividing, are all equivalence transformations that keep the equation balanced. That's what makes them so powerful in solving algebraic problems. Let's look at how to solve different types of equations. When you have an equation like x plus a equals b, the goal is to isolate x. For example, if we have x plus 4 equals 10, we want to undo the addition of 4. We do this by subtracting 4 from both sides, which gives us equals 6. Next, for equations where a variable is multiplied by a number, such as 3x equals 9, we need to do the opposite operation, division. So, dividing both sides by 3, we find that x equals 3. Now, consider equations of the form x minus a equals b. For instance, y minus 6 equals 5. To solve for y, we add 6 to both sides, which results in y equals 11. Finally, for equations involving division, like x divided by a equals b, we do the opposite, multiplication. If divided by 2 equals 6, multiplying both sides by 2 gets us equals 12. The key idea here is that solving equations involves performing the inverse operation to isolate the variable. Whether it's adding, subtracting, multiplying, or dividing, the main goal is to keep the equation balanced while getting the variable alone. This approach is fundamental as we build up our understanding of solving more complex equations later on. Now let's talk about the shortcut method for solving equations by transposing terms. Essentially, when we have an equation and a term is added to one side, we can move it to the other side by subtracting it. For example, if we have x plus 4 equals 10, we can transpose the 4 to the other side by subtracting 4 from both sides, giving us equals 10 minus 4, which is 6. Similarly, if there's a term in multiplication, like 3x equals 12, we transpose it by dividing both sides by 3, so equals 12 divided by 3, which is 4. This is a quick way to isolate the variable. On the other hand, if we have a subtracted term, like y minus 6 equals 5, we transpose it by adding 6 to both sides. So y equals 5 plus 6, which is 11. And finally, when a term is in division, such as y equals 6 divided by 4, we transpose that by multiplying both sides by 4, so y equals 6 times 4, which is 24. The key takeaway here is understanding how to move terms across the equation. Addition becomes subtraction becomes addition, multiplication becomes division, and division becomes multiplication. This method makes solving equations faster and helps you see the process more clearly. All right, let's look at how we can solve an equation using more than one property. The example here is 3x plus 8 equals 14. To solve this, we want to isolate the variable. The first step is to get rid of the 8, and we do that by subtracting 8 from both sides of the equation. When we do this, we're applying the subtraction property of equality, which keeps the equation balanced. So 3x equals 14 minus 8. Simplifying that, we get 3x equals 6. Next, to solve for x, we need to undo what's being multiplied by x, which is 3. So we divide both sides of the equation by 3. This step uses the division property of equality. When we do that, x equals 6 divided by 3, which simplifies to 2. And there we have it. By using subtraction and division properties, we've successfully solved for x. The key idea here is that multiple properties can work together to systematically isolate the variable. This approach is really helpful as it shows how different properties work hand in hand to simplify and solve equations efficiently. All right, let's walk through this step by step. The original equation is 2a minus 3 equals 5. To solve for a, the first step is to isolate the term with a so. We add 3 to both sides, which gives us equals 5 plus 3. This is called transposing the 3, and it helps us move the constant to the other side of the equation. Now, 5 plus 3 equals 8, so 2a equals 8. The next step is to solve for it itself, which means dividing both sides by 2. When we do that, we get a equals 8 divided by 2, which simplifies to 4. So the key takeaway here is that solving for a involves isolating the variable by undoing the operations around it, adding, subtracting, multiplying, or dividing, step by step. This process helps us find the value of a, which in this case is 4. Now let's look at this example. 5n divided by 8 equals 20. The key here is to find the value of n. To do that, we first multiply both sides of the equation by 8 to eliminate the denominator. So 5n equals 20 times 8. Once we have 5n equals 160, we then divide both sides by 5 to solve for n. That gives us n equals 160 divided by 5, which simplifies to 32. The most important takeaway here is understanding how to isolate the variable by performing inverse operations, multiplication and division, in a step-by-step way. This process is fundamental in solving algebraic equations and connects directly to the overall theme of mastering problem-solving techniques in algebra. When solving an equation with a variable on both sides, the key is to get all the variable terms on one side and the constants on the other. This makes it easier to isolate the variable and find its value. Let's look at an example. 10y minus 3 equals 7y plus 9. The goal here is to move all the y terms to one side, in this case, the left, and the constants to the other side, which is the right. To do that, I'll transpose the 7y from the right to the left, and the 3 from the left to the right. Remember, transposing means changing the sign. So, subtract 7y from both sides and add 3 to both sides. This gives us 10y minus 7y equals 9 plus 3. Simplifying, we get 3y equals 12. Next, to solve for y, I divide both sides by 3, which yields y equals 12 divided by 3. And finally, I find that y equals 4. The most important concept here is that transposing terms involves changing their signs, and this helps us group all the variable terms on one side and constants on the other. This method is fundamental because it's a systematic way to solve equations with variables on both sides, keeping the process clear and organized as part of our overall problem-solving toolkit. Now let's walk through the solution step by step. We start with the equation 2 times x minus 5 plus 3 times x minus 2 equals 8 plus 7 times x minus 4. The first thing I do is expand the brackets. So 2 times x is 2x, and 2 times negative 5 is minus 10. Similarly, 3 times gives us 3x, and 3 times negative 2 gives minus 6. On the right side, 8 stays as it is, and 7 times x is 7x, while 7 times negative 4 is minus 28. Next, I combine like terms. The equation now reads 2x minus 10 plus 3x minus 6 equals 8 plus 7x minus 28. Combining the x terms on the left, 2x plus 3x gives 5x, and on the constants, minus 10 minus 6 results in minus 16. So the left side simplifies to 5x minus 16. On the right, 8 minus 28 combines to minus 20, so the right side is 7x minus 20. The goal now is to isolate x, so I bring all the x terms to one side and constants to the other. Subtracting 7x from both sides, we get 5x minus 7x equals minus 20 plus 16, which simplifies to minus 2x equals minus 4. Finally, to find x, I divide both sides by minus 2, giving x equals minus 4 divided by minus 2. This simplifies to equals 2. So that's our solution, equals 2. This process highlights how expanding brackets, combining like terms, and isolating the variable are key steps in solving algebraic equations efficiently. Let's go through solving these word problems step by step. First, we have a problem where a number increased by 8 equals 15. To find that number, I'll let the number be x. The key here is translating the words into an equation. The number increased by 8 becomes x plus 8, and that equals 15. So x plus 8 equals 15. To find x, I subtract 8 from both sides, which gives me equal to 15 minus 8, so x equals 7. Next, there's a problem where a number is decreased by 15, and then this new number is multiplied by 3, resulting in 81. Again, let's call the original number x. The decreased number is x minus 15. When we multiply that by 3, it equals 81. So the equation is 3 times x minus 15 equals 81. To solve for x, we divide both sides by 3, or better yet, expand the equation to 3x minus 45 equals 81. Adding 45 to both sides gives 3x equals 126. Dividing both sides by 3, we find that x equals 42. Finally, there's a story problem about a man and his son's ages. The man is 26 years older than his son. We need to find their current ages, knowing that in 10 years, the man will be 3 times as old as his son. To set this up, I'll let the son's current age be x. That means the father's current age is x plus 26. In 10 years, the son will be x plus 10, and the father will be plus 36. The key is that at that time, the father's age will be 3 times the son's age. So x plus 36 equals 3 times x plus 10. Simplifying the right side, that becomes 3x plus 30. Now I set up the equation. X plus 36 equals 3x plus 30. Subtracting 3x from both sides and subtracting 30 from both sides, I get minus 2x equals minus 6. Dividing both sides by minus 2, I find equals 3. So the son is 3 years old now, and the father is 3 plus 26, which is 29 years old. These problems highlight the importance of translating words into algebraic equations and solving step by step. It's a great way to see how math helps us understand real-life situations.